Okay, in this video we're going to do a little bit more with our trigonometric ratios. So real quick, let's see if you remember what are the ratios for sine, cosine, and tangent of an angle. All right, so I'll give you a moment to see what you can do there. If you want to pause it and write them in, you can. Remember, we learned the mnemonic device SO, CA, TOA. So the SO part means sine with opposite over hypotenuse. Okay, so there's that portion of our ratios. Let's talk about cosine. All right, cosine, CA. So cosine is adjacent over hypotenuse. And then, last but not least, our tangent, TOA. So SO, CA, TOA. And in this case, tangent is opposite over adjacent. And there we are. So again, if this mnemonic device helps you, use it. If you don't need it, don't. Just a quick reminder of what the relationships are. So today, what we're going to use our ratios for is not just finding the ratios. That was your purpose yesterday, just to see that you could do it. Today, we're going to start using it for two purposes. All right. One of the purposes, okay, is to find side lengths. Okay, so find what those sides are. The other one is to find angle measures. All right, so that's the two things that we're going to do today. We're going to use trig to find missing side lengths as well as to find angle measures. And as we're doing this, the method that we'll be using is known as indirect measurement, meaning I'm not going to break protractors out to measure the angles. I'm not going to break rulers out to measure the sides. We're going to use trig to do it for us. All right, remember, because all right triangles that have a certain angle, let's say of 60 degrees, they're all similar. These ratios hold for all right triangles with any given measure. So let's get to it. Set that there. All right, so let's look at our problem here. And I don't mean to read it to you, but it's been a while since I've seen the problem, and I need to read it. So it says a certain part of a hiking trail slopes upward at about 5-degree angle. So here's our 5-degree angle. It's right here. After traveling a horizontal distance, so if we were just to go straight through the earth, of 100 feet along this part of the trail, what would the change in the hiker's vertical position be? So in other words, the hiker's obviously got to stay on the ground. So if we were a mole, for example, and we could just burrow underground this 100 feet, what would be the difference between, say, our hiker and the mole? Okay, and also, what would the actual distance that the hiker, how far would he or she have actually walked? Because notice, while the horizontal distance might be 100, the hiker is going to have to go a further distance. Again, that's the hypotenuse of our triangle. By the way, I notice a lot of folks like to do this. They'll like to write an arrow or something to show from the right angle to the hypotenuse so that they know what's the hypotenuse at all times. All right? So let's figure out the horizontal distance just because we were asked for it first. So notice I'm dealing with this 5 degrees. Okay? And I want to figure out x. Well, notice in this case, from our 5-degree angle, x is the opposite side. So let's think about a ratio that we could create with side lengths. That'll help us figure out what trig function we're going to use. So I know that x is opposite, so let me write that down. So 5 equals, we're going to use the opposite side over, let's see what other side we have. Well, we don't know the hypotenuse, but we sure do know the adjacent side. So I know the opposite side, I know the adjacent side. Well, which of our trig functions does that relate to? All right, and again, if you don't remember your ratios, use your acronym, or excuse me, mnemonic device. I'll get it right eventually. So, CA, TOA. So which one of these does this seem to best match with? Well, I've got opposite, so sine and tangent start with opposite. But notice we also have the adjacent side. So that rules out sine. This looks like a tangent problem. So I'm looking at the tangent of 5 degrees being equal to this ratio. Well, let's actually fill in what we know and use it. So the tangent of 5 is equal to our opposite side. Well, notice we don't know what it is, so we'll call it x, over the adjacent side, which we do know, is 100. All right? So all we have to do now is a little algebra to get x all by itself. So what I'm going to do is I've got to get rid of this 100. Notice it's dividing right now, so I'm going to multiply both sides by 100. Now I'm going to stop for just a minute. Tangent of 5, okay? When we think of this, we have to think of tangent 5 as a value on its own. So what I can't do, I can't multiply 100 by this 5. It doesn't work. We have to deal with the tangent issue first. So tangent 5 is kind of like, for lack of a better word, it's like a variable, a number all on its own. So tangent 5 we have to protect. So when we're going to multiply by 100, we have to multiply the value, tangent of 5, by 100. So we're not going to multiply 105. That doesn't work. We have to figure out what the tangent of 5 is before we multiply by 100. All right, so let's rewrite this. So I know that x, okay, our vertical difference here, is going to be 100 multiplied by tangent of 5. Okay? This is where our calculator comes in. Behold, the calculator. Now, remember, if you watched the other video that I did on just the introduction to trig, you remember that we had to go to mode. And remember, calculators measure angles in two ways, as do mathematicians. Most upper-level mathematicians are going to use what we call radians. So for you guys, when you get to, probably pre-calc calculus, you're going to start measuring your angles using radians from then on out. For the rest of us, say in the elementary schools, middle schools, and high schools, we measure in degrees. So what you're going to do is make sure you arrow over if radians is currently selected, like it is here. Don't do that. Arrow over, make sure that degrees is set, or if you're using a scientific calculator, okay, again, make sure that you are set that way as well. So if you are in a scientific calculator, make sure that you are also set on degrees and not radians. All right, so make sure of that. Otherwise, you get some really weird answers that you don't want. They're correct answers, just not the answers we want. So we'll hit enter, quit out. Now, let's take a look at how we're actually going to enter this into our calculator. So we know what x is. X is 100 multiplied by the tangent of 5. I don't know about you, but I have no idea what that actually is. So let's type it in. So 100 multiplied by tangent 5. Hit enter. So, according to our calculator, it looks like the difference here between our hiker and, let's say, that mole we were talking about is going to be 8 point, let's round to the hundredths position, 75. Let's see, what were we measuring in? Yep, measuring in feet. Okay? So there it is. Now, let's try something. 100, tangent, 5, close parentheses, enter. Notice you get the same answer. So if you put your 100 right up next to tangent, it means multiplication. Same way as if I put, say, 2 right up next to a variable of x. It means multiply. So that saves you that step there of typing in the multiplication sign. Cool. So we know the difference here is roughly 8 3/4, almost 9 feet. All right, well, let's figure out what the distance that the hiker would actually have to walk. So let's separate our work here and see what we get. So let's keep using this angle, 5. Not sure of what trig ratio we're going to use yet, so we'll hold off on that. But let's see what sides we know. Now, we do know this 100 feet is 100 feet. Now, here's why I'm not going to use this 8.75. This 8.75 is a rounded number. So if I can avoid it, I don't want to use it. I want to use numbers that I know with certainty. This is a rounded number. This is a definite number. So I'm going to use it. So I know 100. 100 in this case is the adjacent side, 5. And I'm going to be trying to find the hypotenuse. So let's think about this. Adjacent side and hypotenuse, that sounds a lot like cosine. So the adjacent side would go up top, so 100. Our hypotenuse, in this case y, what we're trying to find, would go down below. And we said we'd be using the cosine ratio. So there it is. Cosine of 5 is going to be 100 over y. All right, well, we're going to work this out the same way we did before. I've got to get this fraction broken up here, so I'm going to multiply both sides by y. So I've got y, cosine of 5, is equal to 100. But notice y still isn't by itself. So what we're going to do is we're going to divide both sides by cosine 5. Now, listen carefully. Just like we did over here, I couldn't multiply this 5 in 100. Over here, I can't divide this 105. That doesn't work. Cosine 5 is a value all its own, and we don't know it yet. So we've got to treat it like a variable. So we end up with y equals 100 divided by the cosine of 5. All right, well, back to the calculator. 100 divided by cosine of 5, close parentheses. And you notice I keep doing that. I wouldn't have to in this case because there's nothing to follow, but it's a good idea to get into the practice of closing those parentheses because we'll be getting to some other work later on where we'll just about fill the screen up with stuff that we type in. And if you don't put those closed parentheses in there, it just really wreaks havoc on your work. So go ahead and get in that habit now. Hit enter. And let's see here. We've got y being equal, and again, we know we're rounding here, roughly 100, and let's call it 38 hundredths feet. And there we are. Now, I'm sure you're asking, well, wait a minute, why did I bother to do trig here if I knew this is 100, and I knew this was 8.75 roughly? Why couldn't I just use, say, Pythagorean theorem? 100 squared added to 8 3/4 squared equaling y squared, and just solved it that way. You could have done it that way just fine, but remember, this is a rounded number. In this case, we could use trig without using any rounded numbers and get to a more exact answer. So that's why I ultimately didn't use Pythagorean theorem here. You could, but remember, if you're using rounded numbers in your work, that means your final answer on that second part is going to be even more off than what it is here. So we know our hiker went roughly a little over 100 feet, not a lot more, but a little bit. Roughly 100 feet and a third of another. And then our difference in height there was just about 9 feet, just a quarter short. All right, so there's one way that we can use our trig ratios to do some indirect measurement. Let's try another one. Well, another few it looks like. So in these top ones, all we're doing is finding the variable x to the nearest hundredth. And then we'll take a look at this problem here, this architecture problem as they call it, in just a moment. So let's try the first one. I've got 25 as my angle. We've got x that we're trying to find here and 18 there. So let's write out our mnemonic device in case you still need it. So, ka, toa. So let's see here. 25 degrees, we'll write it down, equals, notice I've got opposite over adjacent. Opposite over adjacent, because I know this other side that isn't labeled is the hypotenuse. So, opposite over adjacent looks like tangent to me. So tangent of 25 is opposite side, in this case x, over adjacent side, in this case 18. All right, to work that out, we'll simply multiply by 18 on both sides. So 18 tangent 25 is equal to x, which is equal to, so again, grab your calculator. So 18 tangent, what was the angle? 25, close parentheses. Rounding to the hundredths position is roughly 8.39, and notice they didn't give us a unit, so we'll just leave it as is, or if you want, we can write units behind there. So good, so 8 39 hundredths units is the distance for x. Let's try another one. So we've got 70 degrees, so let's jot that down. I've got an adjacent side and a hypotenuse, so again, x is the hypotenuse in this case. So adjacent and hypotenuse, that sounds like cosine to me. So cosine of 70 is equal to our adjacent side, 15, over x. Remember to solve this, we'll multiply by x on both sides. So x cosine 70 is 15. To get x by itself, we'll divide by cosine of 70. Divide by cosine of 70. Which is equal to, let's see here, 15 divided by cosine of 70, close parentheses, call it 43 and 86 hundredths. And we go ahead and write units on there, I suppose. There we are. Simple as that. All right, let's take a look at this architecture problem. All right, it says the front of a vacation cottage, as shown, is an isosceles triangle, so there it is. What is the height, x, of the cottage above its foundation, and what is the length, y, of the roof? And explain your reasoning. Well, let's think about this a minute. We know this is a right angle, okay, because we were measuring the height from the pinnacle there to the ground. If this is 60 degrees and that's 90 degrees, well, that makes this 30 degrees. And if this is a 30, 60, 90 right triangle, that means the other side is going to be a 30, 60, 90 right triangle because we were told the cottage is an isosceles triangle. If that's the case, then congratulations, it's actually equilateral. Oh, they tried to trick us. Well, let's think about this. We know the entire base here of our triangle, or the bottom of our house from corner to corner, is 65. So if I wanted to find, say, this shorter side between these two dots that I wrote here, all we've got to do is take 65 divided by 2, and that finds this shorter side length of 32.5 feet. Now, we could use trig. We could recognize that, for example, this is 60 degrees. I've got an opposite side and an adjacent side. So opposite and adjacent, get our trig there. Opposite and adjacent is tangent, so we could go that route. However, wouldn't it make more sense, instead of reaching for trig, wouldn't it make more sense to go back to what we know about special right triangles and go that route? So, for example, we just said that this is an equilateral triangle, so we know that side y is also going to be 65 feet. Explaining that is relatively simple. It's an equilateral triangle, so if this side's 65, that side's 65. Not to mention, it's also double this shorter side. So that's easy. Let's figure out x. X is pretty simple, too. We'll just take this 32.5 and multiply it by radical 3. Now, in this case, if they did want an approximated answer, so that way we have some idea, because I don't know what 32.5 multiplied by square root of 3 is off the top of my head. That means nothing to me. But if we do want to know the actual height and give something to go on, remember when we type this into our calculator, 32.5 multiplied by the square root of 3, close your parentheses, get in the habit of that, we can see that the height of our triangle in this case is approximately 56.29 feet. So there we are. So it's just a little bit over 56 feet tall. We know our short side there was 32.5, and we use that to find that the other side is 65 feet. So again, you don't necessarily have to use trig in some cases. In this case, we know it's a 30, 60, 90 right triangle. Use what you know about your special right triangles to figure it out. You don't have to reach for trig every single time. Now, so far all we've been doing is finding side lengths, okay? If we use the inverse of our trigonometric ratios, then what that will do is that will allow us to find angle measures, all right? So for example, if I know that the sine of A is x amount, then the inverse of x is the measure of angle A. So on your calculator here, take a look. You've got all of your trig functions here. You've got sine, you've got cosine, you've got tangent. But a second function, if you look above there, is sine, and it looks like a to the power of -1, and a cosine to the power of -1, and tangent to the power of -1. The way that's read is not sine to the negative first, cosine to the negative first. The way it's read is the inverse of sine, the inverse of cosine, so the inverse of tangent. Okay? Or you could say, for example, we could read this, the tangent of A is x, then the inverse of tangent x is A, or in this case, the measure of angle A. So, our calculators have this, and we can use it then as a way of going back and forth. So let me show you. It's easier to show you than it is to try to explain. So, again, we have inverses of all of our ratios that help us find angle measurements. So take a look at this one. This problem's different. With this problem, we know that this is 90 degrees, but we have absolutely no idea what these other two angles are. If we need to find them, we can use our inverse of our trigonometric ratios to figure it out. So in this case, we're asked to use a calculator to find the measure of angle A to the nearest tenth. All right, well, let's do that. So I know that the angle I'm using is A equals, and let's see, the two sides that I have available to me are the hypotenuse and the opposite side. So that sounds a lot like sine to me. So sine of angle A is the opposite sides, in this case 18, over the hypotenuse of 27. All right. So as it's currently written, we have no way of figuring this out. And what in the world could this angle be? I mean, we can sit here and guess and check if we'd like, but there's a better way. In order to move sine, or any of our trigonometric ratios, from one side of an equation to the other, what we'll use is the inverse. So the way we can write this is that A equals the inverse sine of 18 over 27. And this will ultimately be what we'll type into our calculator to figure out what the measure of angle A is. So some people would prefer us to write the measure of angle A is equal to what we have here. So let's do that. So the measure of angle A